Hello, welcome back. Today we are doing a lesson that should technically be 100% review. So far we've looked at patterns for mass and patterns for size. The next three patterns we learn are going to center around electrons and what electrons do. Now, we already know a lot about electrons. Since we're talking about patterns with electrons, let's go ahead and make that table we're getting really good at. Now, this time it is going to be important not how many middle blocks you have, but you do want to make sure you have the right number of columns. So this is 1, 2, 3, 4, 5, 6, 7, and then 8 is up. So we do want to make sure we have the right number of columns since we are going to be looking at electron trends by column. And then I actually want you to drop the columns down. So just go ahead and fill them in. That way we have a nice visual reminder. We're looking at columns and how electrons behave within columns. All right, so when we talk about columns, remember we usually skip the middle. 1, 2, 3, 4, 5, 6, 7, 8. So when we talk about columns, we talk about columns 1, 2, 3, 4, 5, 6, 7, 8. The electrons in the transition metal block behave really funny. So we don't usually model how the electrons are behaving in that middle block at this level. If you take Gen Chem and Gen Chem 2, you'll start to learn a little bit more about them, but just as some background information, the electrons in the main block always fill the valence shell. So the most recent added electron always goes on the outside ring. These electrons actually fill shells either 1 or 2 shells back. So when you add electrons, they don't always go into the outside ring, so sometimes it's kind of hard to track where they're at and where they're going. So at our level, we only focus on these main block elements because they follow more clear-cut patterns. Now, within these main block elements, we're going to be looking at how electron trends change in these different columns. So in order to look at these column changes, we're going to look at all of the elements in row 2. Because by looking at an element in row 2, we look at one element in every single column. Again, I just usually pick row 2 because they're small enough that we can draw them and talk about them a little easier. Whereas if we're trying to draw and model francium, we're trying to remember where 87 electrons go. So we're going to stick with row 2. All right, row 2. So there goes the clock again. Sorry. Row 2. We are going to look at lithium. So I want us to draw lithium. Now, we're not going to draw full Bohr models. We are only going to draw the electrons in the valence shell. So lithium has 3 electrons. 2 of them are going to fill the first shell. Sorry. And 1 of them is going to be left in that shell 2 by itself. So give lithium a dotted line. And I would change colors so you can easily see it. And it has 1 electron hanging out in its valence shell. I'm going to put that electron right here. And then we keep working across the row. So beryllium. Again, we're just drawing a valence shell, so we're only ever going to have 1. Now, beryllium has 4 electrons, 2 of which are in shell 1, 2 of which are going to be in the valence shell. So beryllium, that is not a great color to show up, sorry about that, has 2 electrons in its valence shell. Next, we have boron. And boron has 5 electrons. 2 electrons fill the first shell, and then the remaining 3 go in the valence shell. So boron has 3 in the valence shell. Then we go to carbon. Carbon has 6 protons, therefore 6 electrons. 2 are in the first shell, 4 are in the valence shell. So carbon has 4 in the valence shell. And you've probably started to notice a pattern, but we'll keep going. Nitrogen has 7 electrons. 2 of them go in the first shell, leaving 5 in the valence shell. And oxygen has 8 electrons. 2 in the first shell, 6 in the valence shell. 2 more. Fluorine, oops, that's going to be a little close, has 9 electrons. 2 are in the first shell, leaving 7 in the valence shell. And last but not least, neon has 10 electrons. 2 are in the first shell, and the 8 remaining will actually fill up the valence shell. So neon has a full valence shell with 8. So looking at row 2, so this would be column 1, column 2, column 3, 4, 5, 6, 7, 8. We now have an example of how those atoms look in each of our sample columns. So this is column 1, 2, 3, 4, 6, 7, 8. Next thing I want us to do is, where's my black marker? All right. Next thing I want us to do is look at the LewisDot structures in these columns. So for each of these atoms, we're going to take that Bohr model and transition it. Remember, it's a half Bohr. I didn't draw every shell. I just drew the valence shell. And transition it into a LewisDot structure. Now, for a LewisDot structure, it is important that you put the dots in a specific location. So when we fill a LewisDot, we fill in a particular pattern. So for example, lithium has 1 valence electron. So on its LewisDot structure, we denote 1 valence electron at what would be like 3 o'clock on a clock. Beryllium has 2. So we put 2 valence electrons at 3 o'clock. Boron has 3. So we put 2 valence electrons at 3 o'clock and 1 valence electron at 12 o'clock. Carbon has 4 valence electrons, 2 at 3, 1 at 12, 1 at 9. Nitrogen has 5, 2 at 3, 1 at 12, 1 at 9, and 1 at 6. Oxygen has 6. Two, 2, 1, and 1. Fluorine has 7. And neon is full with 8. So for each column, we now have an example of a Bohr model and a LewisDot. And hopefully the pattern is obviously clear. Elements in column 1 have 1 valence electron. Elements in column 2 have 2. Skip the middle because they do funny things with their valence electrons. 3 has 3, 4 has 4, 5, 5, 6, 6, 7, 7, and 8 has 8. So I want us to draw a general valence structure in each of our columns. So put a little X going across row 2. We're going to draw example Lewis dots. Now, helium is special, so do put a little HE up in that corner because I do want to denote what helium looks like. So 1 dot in column 1, 2 valence electrons in column 2, 3 and 3, 4 and 4, 5 and 5. Oops, I messed that one up. All right. Hopefully you did not mess that up with me. So 5 looks like 2 on the left and then 1 in each of the other corners. 6 has 6. So 2 on the right, 2 on top, 1 in each of the corners. 7 has 7, 2 on the right, 2 on the top, 2 on the left, and 1 on the bottom. And noble gases are full with 8. The only exception is helium. Because it is so small, it's still full like the other noble gases, but it only has 2. So when we look at column number in Lewis dot, column 1, 1 valence electron. Column 2 has 2, 3 has 3, 4, 5, 6, 7, and 8. The only exception to the rule is helium, which only has 2 because it is such a small atom that it doesn't even have 8 total electrons. So it fills its first shell up instead of filling up a larger shell with 8. It fills up the first shell with 2. All right, so those are our electron trends. This should have been reviewed. This should be stuff you know. If it's not stuff you know, hopefully it clicked now. Hopefully you're kind of remembering that and it's coming back from that atomic structure unit. But general pattern. The column number is equal to the number of valence electrons. The row number is equal to the number of electron rings. So these are the electron trends you should know. You should be very comfortable with them. If you're given an element right here, you should know immediately. 7 valence electrons, 1 away from a full shell.